Hi there! In this video, I'm going to take a look at some SQL black magic. I have here a query that returns no rows. However, it takes a little while to do so. So I'm going to create an index for it. Do that, run the query again, and we get an error. Why did that happen? Let's take a look at the table. We go down, we can see we've got customer IDs and dates stored as strings. And some of those strings hold some suspicious looking dates. However, that's okay. We've got this flag here to tell us whether or not the string holds a real date. The query checks this flag in an inline view. So Oracle processes this part of the where clause first. This means it's only applying the toDate on strings that are in fact real dates before finally checking whether or not they're greater than sysdate. Right? Wrong. You see, the optimizer is smart. It can take a query and rewrite it to something completely different. In this case, it rewrote it like so, removing the inline view. Okay, so the inline view doesn't guarantee order of execution. So why is adding the index causing the query to fail? To find out, let's take a look at the plans. Without an index, Oracle does a full table scan. It applies the search criteria in this order. So it's first discarding the rows where invalid date is not null. Then it removes the rows where customer ID is not equal to 1, before finally converting the remaining string to a date and checking whether or not it's greater than today. So why does adding the index cause the query to fail? Here's the explain plan with the index in place. Notice it looks different, and it applies the predicates in a very different order. Critically, it converts the string to a date before checking whether or not it is a valid date. So we walk through the process again. First, it discards the rows where customer ID is not equal to 1. Then it applies toDate to the remaining strings. And at this point, we get the exception. So how can we solve this problem? Before we answer that, a couple of assumptions. First up, the invalidate flag is always correctly set. If this is null, then that string maps to a real date. Secondly, converting those strings to real dates is off the table, at least for now. What else could we try? We could add a regular expression to validate that the string is indeed a date. But now you've got two problems. And this still allows some dodgy looking dates. And we haven't even thought about leap years yet. This isn't looking good. What else could we try? It would be good if we could modify the index so it only included the values where the string mapped to a real date. Fortunately, you can do this with a function-based index. One way to do this is with case. Use this to check whether the flag is null. If it is, return the string converted to a date. Otherwise, return nothing. Let's see this in action. First, we drop the old index. Then, we create the new FBI. Run the query again, and it works. But there's a problem with this method. Looking at the plan, we can see Oracle isn't filtering the dates in the index. So we may as well have created it just on customer ID. For Oracle to use functions in an index, the expression in the index must appear in the query. This isn't the case here. To use the full index, we need to change the query like so. This works. The query is messy. It'd be nice if there was a tidier way to write this. Which brings us to virtual columns. Instead of hiding the case expression in an index like this, we could add a column to the table based on it like this. This gives us a column that only has values for strings that map to real dates. And, just like a normal column, we can index it. To use this, we still need to change the query, but instead of a messy case expression, we can use the virtual column. Problem solved! So what's the moral of this story? First up, the optimizer is smart. It can take your query and rewrite it in ways you didn't expect. If you try and outsmart it, there's a good chance you'll lose. But all of this is really a long-winded way of saying, don't store dates as strings, or numbers either for that matter. Doing so puts your database on a shaky foundation, which can easily come crashing down. Store a date in a date. Believe me, you'll save yourself a lot of pain. Thanks for watching. If you enjoyed this, then please subscribe to my YouTube channel for more SQL magic.